Hello, welcome to this class. Before I start this class, I would like to share something. I have come across a lot of people who would say maths is difficult, but I don't think it's really difficult. I think they're not able to connect to it because they feel it is disconnected from the real life. They're not able to connect it to the real life. So I think if we get to connect it to the real life, it can be easier, much easier. So thinking about that, I'd like to discuss today's topic. So, without disclosing what the real topic is, I'd like to start it with something so that you can connect with it. In maths, we have solution to everything. So, when in our surroundings, changes happen. In maths, we have a language that is called differentials. Now let's see what is that. You must be familiar with this thing. Right? Yes, you're absolutely right. This is rate of change of y with respect to x. So it tells us that how y changes as the x changes, right? So this is called derivative. So derivative tells you about the rate. I think it's clear, and you knew it already, I think. So now, since we're talking about change, the rate of change, so how the thing is changing. But what about that small change that is happening because of that rate of change? So if I write it like this, what is this? It means small change in y and here it means small change in x. So when we talk about that change that occurs, now if I write it like this, what does this mean? Now, before writing it like this, if I write it like this, you see this is the derivative, right? So now we have derivative of a function, which is this, right? But we don't know what the function is. So here comes the catch. We need to start thinking reverse. So this is called reverse thinking. Why do I say reverse thinking? Because see here, now we know the derivative of function, but we don't know, but what's that function? So now we want to find that function. So we want to go back. So that's why we do reverse thinking. So how do we do that? You see, you have something, you break it into small pieces, right? Let's say those small pieces are like this. These are the small changes, right? If you put them together, you get the complete y, right? So we call this integration. So now in order to find that function, we do integration. So we give the symbol to integration. Talking about this differential equation of ours, let's solve it. So here, this is the derivative, which is equals to this, right? So I can write it like this. Small change, and this is a small change in x, and this is in the y. So we want to know what the function y is. So we need to do integration. Now, if you put all small pieces, all the small changes in y together, you get y only, back again, right? It's like a long distance and you are dividing it into small pieces. When you put it all together, you get the complete distance. So that's why integration of these small changes in y sum up to y itself, right? And here, we take up the constant and we apply it on the x squared. For this, we have formula x raised to power n dx. When integrated, it is like this. So we're going to do same here. So it is plus c. Now you must be curious about it, right? So let's talk about it. So now we have our function equals to 2 upon 3 x raised to power 3 plus c. Now let's talk about this thing. So now, coming to the c, this is called constant of integration. This is constant, okay? So we need to now discuss why do we put this constant here. So now, if I ask you, tell me the derivative of this thing. Let me do this for you. You're gonna do with respect to x. This is gonna be 4 and this is gonna be 0, right? So let's think here. If I go back from here, reverse, I am not able to find what it is because now it has vanished. It's gone. Even if I go reverse, I'm not able to find it, what it was. But I still know that if something has vanished, it must be a constant. So in order to keep that possibility, I need to write the constant here. For that, I write c. It may be a constant, but still with a lot of possibilities for our constant. Different values gives us different curves, right? So function changes accordingly. So that's all in this class. See you in the next class. Till then, bye-bye. Okay, before you finish watching this video, I would like to share something with you. You know, formulas of integration are really difficult to learn or memorize. But have you ever wondered you were able to memorize your favorite song live because you're able to listen to it all the times with this musical theme? So you can click on the link below and check. I have put a song which will help you memorize those formulas in the easier way. Please go and check it once. You might like it. And thank you for watching this video.